Hello, I am Otri Roy, a BSc Honours Data and Artificial Intelligence student here at IIT Guwahati, and in this video, I'll be walking you through my internship project, which was Cyclic Vectors, a three-dimensional approach, a machine learning model in a differential module. So, when we hear the entire project term, the first thing that comes is cyclic vectors. So, what is a cyclic vector? A cyclic vector is referred to as a vector whose each element, when we go for a continuous derivative of it, it generates the entire vector space. So the next question can come, why cyclic vectors out of the blue? So we all have heard the word of differential equations in physics and mathematics, and that's a very common term which we all have been well aware in our high schools and our university levels. So in differential equations, we represent a system in matrix form in a high dimensional system. So what the cyclic vector do? The cyclic vector, it reduces the n matrix for a differential equation to a single value differential equation. So that's a huge jump. So for that reason, we need cyclic vectors, and cyclic vectors also play a very crucial role in differential Galois theory, p-acyclic differential equations, linear algebra, algebraic geometry, and computational algebra. So this is the main purpose, but when I was first introduced to the concept of cyclic vectors, I felt it to be a pure theoretical mathematics. But when I went deep into the concept, especially when I was exposed to the paper of Nicholas Card's A Simple Algorithm for Cyclic Vectors, I found out that there's a need of a machine learning approach as well. And I got my research question that was, can I teach a machine learning to model and understand and predict an algebraic property that is traditionally verified symbolically? Now a question may arise, why so? I will be walking you through in this video. So I worked with three-dimensional module. So three-dimensional module, as I have explained in the definition of cyclic vectors, that is going to be repeated derivatives. So repeated derivatives as we are increasing the dimension from 2 to 3 to 4 to 5 to 6 to 7 to more on and on. So the higher derivation increases. So as the higher derivation increases, the computational cost also increases. So that is a bottleneck over here. So to understand this problem, I came up with two solutions. Build a symbolic pipeline to verify the cyclicity in the CADS algorithm. CADS algorithm refers to algorithm given by Nicholas Card. So he has given a universal cyclicity theorem with which we can determine if a vector of given basis is cyclic or not, and some parameters as well. So one more thing to keep in mind, Zariski topology has told that if the cyclic vector, if the CADS matrix is cyclic at any point, then it's called cyclic everywhere. So how are they determining cyclicity? If it's invertible in nature. So for that we need to find the rank and the determinant. Again, computational cost increases. So here machine learning comes into play, and for that I'm exploring if a machine learning model can predict a cyclicity from algebraic features. So the key term is algebraic features rather than numerical features. So for the input, I'm having a connection matrix, a basis of vector space, and shift parameters. The shift parameters, because they would be helping me to find out at that evaluation point if it is cyclic or not. Then I build the vector, the derivatives, the higher derivatives. So with the Python and SumPy, I automate the symbolic differentiation, determinant computation, and rank evaluation. So instead of feeding the raw symbolic expressions, I am feeding algebraic features. Now a question may arise that why algebraic features? Because of the fact that machine learning is far more approximate and symbolic verification is exact but slow. So for that reason, I'm going with the algebraic features. I'm using 27 algebraic features, and the features are all generated from the input set that I'm taking the connection matrix, the vector space, and the parameters. What are they? The trace, the determinant, rank of the connection matrix, eigenvalue statistics, norm and rank of the basis matrix, shift and evaluation parameters. Now, in machine learning, there are three types of machine learning available: supervised, unsupervised, and semi-supervised. I'm going to supervised machine learning. Now in supervised machine learning, there are multiple models. which one I am using. I am using a random forest one. Now question may arise, why suddenly a random forest when we have a number of models available? Random forest models nonlinear interaction between algebraic features, and one thing to keep in mind, I'm using 27 algebraic features, so random forest works the best with them. So I will be using the random forest one. Now the results. I had an accuracy of 97.05%, AUC of 0.92.222, and very less false negatives and classifications. The misclassifications were mostly seen in the degenerative classes. So now what has my project contributed? Mathematical contribution. It demonstrated abstract algebraic property like cyclicity has statistical structure because I'm using eigenvalue statistics. The computation contribution, it's a hybrid pipeline that first symbolically verifies for correctness and then uses machine learning for speed. We have to keep this one thing in mind: machine learning is not removing the theoretical formulation process, it is increasing the speed for automation. And it has also opened the possibilities for high dimensional differential system, p-acidic, and automated reasoning in algebra. Future work, I have worked for n is equal to 3, but that's a 3-dimensional one, but the work can be extended to much higher dimensions as well. And Andrea Pulita has also given a theory of small connections of cyclic, which is based upon Nicholas Carr's theory. So there also we can also extend it with the help of machine learning for automation, and the various branch of higher dimensional differential algebra can also be extended with the help of machine learning and this theory keeping the baseline. So this theory of cyclic vectors and the machine learning model, which I have done as my internship project, serves as a baseline and the starting stone for much more expansions to be done in the field of differential computational algebra. Thank you.